Chapter 9. Methods of Separation in Everyday Life. Learning Objectives. By the end of this chapter, students should be able to understand and define various separation techniques like handpicking, threshing, winnowing, sieving, evaporation, sedimentation, decantation, filtration, churning, and magnetic separation. Explain how these methods are used in daily life, such as cleaning grains, winnowing, refining flour, sieving, making butter, churning, and purifying water, filtration. Identify which physical properties, size, weight, magnetic property, solubility are utilized in each separation technique. Design basic experiments to demonstrate separation methods, such as creating a simple water filter or using a magnet to separate iron filings from sand. Realize the value of these techniques in daily life and industries for quality, safety, and effective resource management, and strengthen observational skills by noting differences in mixtures and determining the appropriate separation method for each type. Summer vacations are a wonderful time to explore new places and learn new things. Imagine going on a trip across India, discovering not only the beautiful sights but also the fascinating methods people use to separate different substances in their daily lives. From the moment you wake up to the time you go to bed, various methods of separation are at work, making our lives easier and more organized. For instance, think about how your parents separate salt from sand when they're cooking, or how they filter water to make sure it's clean and safe to drink. Every day we encounter various mixtures, whether it's the soil in the garden, the tea we drink, or even the way we sort laundry. Each mixture requires a different method of separation to get the components we need or want. In this chapter, we will explore some common methods of separation used in everyday life, such as handpicking, threshing, winnowing, filtering, sieving, and evaporation. These methods help us manage and use different materials more effectively, and understanding them can make us more aware of the science behind our daily routines. Handpicking. Handpicking is one of the simplest methods of separation used in everyday life. It involves manually picking out impurities or unwanted substances from a mixture by hand. For example, before cooking rice or lentils, small stones or unwanted grains can be removed by handpicking. This method is best suited for separating slightly larger and easily visible particles where the differences between the substances are easy to see and pick out. Handpicking is commonly used when the quantity of the mixture is small. The unwanted material is different in size, shape, or color from the rest of the mixture. The substances to be separated are large enough to be handled easily. Though it's basic, handpicking is a useful method in households and helps ensure that we get rid of unwanted particles before using the materials. Threshing. Threshing is the process of loosening and separating the edible part of grain like wheat, rice, or pulses from the chaff, straw, or stalk. This method is generally used after crops are harvested. There are different ways to perform threshing. Manual threshing in rural areas or on small farms. Threshing is often done by beating the harvested crop against a hard surface, such as a stone or wooden board. This knocks the grains loose from the stalks. Threshing with machines on larger farms. Machines called threshers are used. These machines help separate the grain from the stalks more efficiently. Threshing is a vital step in the agricultural process because it ensures that the grains are separated and can be stored or used as food. Without threshing, it would be difficult to extract the grains from the rest of the plant. Even though threshing is mostly used in farming, it is an example of how separation methods are part of daily life. It highlights how food we consume undergoes various processes before it reaches our plates, including separation methods like threshing. This method of separation makes sure we have clean and usable grains to cook and consume. Winnowing. Winnowing is the process of separating lighter impurities from heavier grains or seeds by the action of wind or moving air. It is commonly used by farmers to clean harvest. Winnowing. Winnowing is the process of separating lighter impurities from heavier grains or seeds by the action of wind or moving air. It is commonly used by farmers to clean harvested grains before storing or using them. There are different ways to perform winnowing. Manual winnowing. In rural areas, farmers perform winnowing by holding a winnowing basket filled with the mixture of grains and chaff. They throw the mixture into the air, allowing the lighter chaff to be blown away by the wind while the heavier grains fall back into the basket. Mechanical winnowing. For larger scale operations, mechanical winnowing machines are used which blow air through the mixture and achieve the same separation effect more efficiently. Winnowing is crucial in ensuring that only the clean, heavier grains remain for consumption or storage. It helps remove unwanted lighter materials such as husk, dirt, or small pieces of straw that are not useful. Though winnowing is primarily used in agriculture, it is a common separation technique in everyday life. For example, it may be used to clean grains like rice or wheat before cooking. Winnowing ensures that we get pure and clean grains free of unwanted impurities, making it an essential process in the food production chain. Sieving. Sieving is the process of separating smaller particles from larger ones using a sieve. A sieve is a tool with a mesh or a net that allows only particles of a certain size to pass through while retaining the larger ones. There are different ways to perform sieving. Manual sieving. In households, sieving is often used in the kitchen to separate fine flour from larger particles or impurities like bran. The flour is placed on the sieve and shaken so that the fine flour passes through the holes, leaving the coarse particles behind. Industrial sieving. In industries like construction, sieving is used to separate sand from pebbles or larger stones. Sieving machines with different mesh sizes are used to achieve large-scale separation. Sieving is a quick and easy method for separating materials based on their size. It ensures that unwanted larger particles are removed, leaving behind only the fine desired substance. Sieving is a part of many daily tasks. In cooking, it helps in refining ingredients like flour, sugar, or spices. In construction, sieving ensures that only fine sand is used for plastering or cement work. This method helps improve the quality and consistency of materials, making it a crucial separation technique in both household and industrial processes. Evaporation. Evaporation is the process of separating a liquid from a dissolved solid by heating. When a solution containing a dissolved substance like salt or sugar is heated, the liquid, usually water, evaporates and turns into water vapor, leaving the solid behind. There are different ways to perform evaporation: boiling and heating. The mixture is heated until the liquid starts to evaporate. As the water vapor escapes into the air, the solid particles are left behind in the container. This is how salt is obtained from seawater. Natural evaporation. Sometimes evaporation happens naturally when water is left out in the sun. Over time, the water evaporates and the dissolved substances remain. Evaporation is a natural process and is essential for various applications. Obtaining salt from seawater. This is one of the most common uses of evaporation. Seawater is collected in shallow ponds and left to evaporate in the sun, leaving salt crystals behind. Salt is a daily necessity for everyone. Drying clothes. When wet clothes are hung outside, the water evaporates, leaving them dry. Cooking. Evaporation is used in cooking when liquids are reduced to concentrate flavors, such as in sauces or syrups. Evaporation is a simple yet highly effective method of separating a solid from a liquid and is useful in various household and industrial activities. Sedimentation and decantation. Sedimentation and decantation are two methods often used together to separate mixtures. Sedimentation. Sedimentation is the process of allowing heavier particles to settle at the bottom of a liquid. It works based on the difference in density between the solid particles and the liquid. The solid particles, being heavier, gradually sink to the bottom when the mixture is left undisturbed. For example, a mixture of water and an insoluble solid like sand or mud is left undisturbed for some time. The solid particles slowly settle to the bottom, forming sediment. Decantation. Decantation follows sedimentation. Once the solid particles have settled at the bottom, the clear liquid at the top is carefully poured off without disturbing the settled solids. This process separates the liquid from the solid sediment. These methods are useful in everyday life and industrial applications. Water purification. Sedimentation is often used in water treatment plants to remove suspended impurities before further purification. Separation of mud and water in rural areas. Sedimentation and decantation are used to separate muddy water and obtain clear water for household use. Cooking. Sedimentation and decantation are used to separate impurities from rice or lentils. Before cooking, the water with impurities is poured off after the sediment settles. Oil and water separation. In cases where oil is mixed with water, sedimentation and decantation can help separate the two, as oil floats above water due to its lower density. Making juice. In homemade fruit juices, after blending, the solid pulp can settle at the bottom. Decantation can then be used to separate the clear juice from the settled pulp. These methods offer a simple, natural way to separate solids from liquids and are commonly used in various situations in our daily lives. Filtration. Filtration is the process of separating solid particles from a liquid by passing the mixture through a filter. The filter allows the liquid to pass through while trapping the solid particles, effectively separating them. Filtration relies on the size difference between the solid particles and the liquid molecules. A filter, often made of paper, cloth, or mesh, has tiny pores that allow the liquid to pass through while blocking the larger solid particles. Steps of filtration. Prepare the mixture. A mixture of an insoluble solid like sand, tea leaves, or chalk powder and a liquid like water is made. Place the filter. A filter paper or a sieve is placed over a container to collect the liquid. Pour the mixture. The mixture is slowly poured onto the filter. The liquid passes through the filter paper, leaving the solid particles behind. Separation complete. The clear liquid called filtrate is collected in the container below, while the solid particles called residue remain on the filter. Filtration is widely used in various situations. Water purification. Filtration is a critical step in water treatment plants to remove dirt and other impurities from water before it is supplied for household use. Brewing tea or coffee. When brewing tea or coffee, the liquid passes through a filter like a strainer, which keeps the solid tea leaves or coffee grounds separate from the liquid. Air purification. Filters in air purifiers trap dust particles, allowing clean air to pass through. Cooking. While making tea, tea leaves are filtered out using a strainer, leaving only the liquid tea to be consumed. Juice extraction. When extracting juice from fruits, a sieve is often used to separate the pulp from the juice. Washing rice or vegetables. Filtration is used when rinsing rice or vegetables. The water drains away, while the solid food remains in the strainer. Chemical laboratories. In chemistry labs, filtration is used to separate precipitates from liquids during experiments. Pharmaceutical industry. Filtration is used to purify chemicals and medicines by removing unwanted solid impurities. Homemade paneer cheese. When making paneer, milk is boiled and curdled by adding lemon juice or vinegar. The curdled milk is then passed through a cloth, which acts as a filter, separating the solid curd paneer from the liquid. Filtration is a simple yet effective way of separating solids from liquids and is utilized in countless situations in both daily life and industry. Churning. Churning is a process used to separate butter from curd. Here's how it works. Curd preparation. Milk is first turned into curd using a bacterial culture. Churning. The curd is then placed in a churner and agitated or stirred vigorously. This action separates the butter fat from the buttermilk. Separation. The churning process causes the butter fat to clump together and rise to the top as butter, while the liquid part known as buttermilk is left behind. Applications. Butter production. Used to make butter from curd in kitchens and dairy farms. Traditional practices. Common in many cultures as a way to obtain fresh butter. Examples: churning curd in a traditional churner or matani to make butter. Modern dairy farms use mechanical churners for large-scale butter production. This method of separation is a practical example of how physical processes can be used to separate different components of a mixture based on their physical properties. Magnetic separation. Magnetic separation is a process used to separate magnetic materials from non-magnetic ones. Here's how it works. Magnetic materials such as iron filings are attracted to magnets due to their magnetic properties. Separation process. A magnet is used to attract and pull out the magnetic materials from a mixture. The non-magnetic materials remain behind. Steps in magnetic separation. Prepare the mixture. Start with a mixture containing magnetic and non-magnetic materials. Apply a magnet. Pass a magnet through the mixture. The magnetic materials will cling to the magnet. Separate the materials. Remove the magnetic materials from the mixture and set them aside. Applications. Recycling, separating magnetic metals from waste to recover iron or steel. Mining, extracting iron ore from other minerals. Food industry, removing metal contaminants from food products. Examples: using a magnet to remove iron filings from a mixture of sand and iron filings. Employing magnetic separators in recycling plants to sort out metal scraps. Magnetic separation is a simple and effective method to separate substances based on their magnetic properties, making it useful in various industrial and everyday applications. Keywords: churning, the process of shaking or stirring to separate cream from milk. Decantation, pouring off liquid from a settled solid or sediment. Evaporation, the process of turning liquid into vapor by heating. Filtration, using a filter to separate solid particles from liquids or gases. Handpicking, separating items by picking them up by hand. Magnetic separation, using a magnet to remove magnetic materials from a mixture. Mixture, a combination of two or more substances that can be separated. Sedimentation, the process where solid particles settle at the bottom of a liquid. Sieving, using a sieve to separate particles of different sizes. Threshing, separating grains from stalks by beating. Winnowing, using wind or air to separate lighter particles from heavier ones. Create, to make something new. Design, to plan or make a drawing of something. Experiment, a test or trial to discover something. Explore, to look into or examine something carefully. Infer, to make a guess or conclusion based on evidence. Investigate, to examine or study something closely. Observe, to watch or notice something carefully. Overview. Handpicking separates solid materials by size, color, and shape from a mixture. Threshing beats stalks to separate grains from them. Winnowing uses wind or air to separate lighter husk from heavier grains. Sieving separates solids from a mixture based on particle size using a sieve. Evaporation converts a liquid into vapor to separate a solid dissolved in it. Sedimentation involves heavier insoluble particles settling at the bottom of a liquid. Decantation removes the liquid after sedimentation by tilting the vessel. Filtration separates insoluble solids from a liquid using a filter. Churning extracts butter from curd. Magnetic separation uses a magnet to separate magnetic substances from non-magnetic